let's now discuss some arbitrary exponential functions in the context of integration. So what we want to do here is we want to find the integral of 3 to the x dx. Now remember, the integral of e to the x dx is just e to the x plus c. Don't forget your arbitrary constant. So if we recall that the derivative of e to a number times x is just that number times e to that number times x, so that constant sort of replicates itself, then we can get an antiderivative by dividing by that constant instead of multiplying. And since an arbitrary base is just e to the natural log of a times x, what we can do is we can say, okay, well that's just e to the natural log of 3 x dx, which is 1 or natural log of 3 to the natural log 3x plus c, which then we can rewrite as 1 over natural log of 3 to the x plus c. Now what we want to do is we want to get to a point where we're not doing this piece, because that's a lot of work to just get here. So what you notice is that when you take the antiderivative, you get the original function divided by the log of the base. So that's how we want to think about these problems. The original function divided by the log of the base. So for this type of problem, we're still going to have to use substitution, but we can leverage this result. So what we want to do is we want to say, okay, that argument is nasty, sine of x. So let's substitute u to be sine of x. We say u is sine of x, du is cosine of x dx. So then we can absorb that. Okay, so this now becomes 4 to the u du, right? This becomes du, this becomes u. Okay, simple enough. So we can leverage this result to say, okay, that's 1 over natural log of 4 to the u plus c, and then we started in x's, so we have to end in x's. So 1 over natural log of 4 to the sine of x plus c. So that's how we get to that particular result. Not too bad. And in this case, we want to evaluate a definite integral. So we're going to do a very similar process. We're just going to kind of walk through the motions. Now in this one, you get the same type of result. You say, okay, the antiderivative of 6 to the x is 1 over natural log of 6 times 6 to the x minus 1 over natural log of 5 to the x. And recall, you don't need your arbitrary constant because you're doing a definite integration, so you can drop the arbitrary constant. You could use it if you wanted to, but it would end up getting subtracted out. And so we go from 1 to 3. So what we're going to do is we're going to evaluate it when x is 3. We're going to say, okay, 1 over natural log of 6 cubed minus 1 over natural log of 5 times 5 cubed. So that's evaluated at x equals 3. And then we subtract the case where we're evaluating where x is 1. So 1 over the natural log of 6 to the first power, minus 1 over natural log of 5 to the first power. Now 6 to the third power is 216. So we have 216 or natural log of 6 minus 125 natural log of 5, and then we have minus 6 natural log of 6 minus 1 natural log of 5. So we notice that these two have the same denominator, so we can combine them. So if I distribute this negative, what I get is negative this, but then positive that, because that becomes negative, those negatives cancel. So combining common denominators, I have 210, or natural log of 6, minus 124 natural log of 5. So let me check. For some reason I feel like that doesn't match my notes. And it doesn't, because I wasn't thinking. So it's 5, and that's 120 over natural log of 5. But other than that, that's the correct answer.